Hello, good day. Once again, this is Jesse Anang. I'm here today to talk about programming using C++, and this is the chapter 2. And under this chapter, we are going to talk about the data type, constants, and variables. My name is Jesse Ajete Anang. So before we go on with the concept of C++, C++ is also part of the object-oriented programming language, and it was built on the concept of C. So we'll start by talking about the various things that has to do with data type, constants, and variables. I've already created the chapter 1 of this course, and I hope that you would get the video of the chapter 1 and then you follow on with the chapter 2, where we'll be talking about the data types, the constants, and then variables. So let's proceed. So programming C++, data types. A program can use several data to solve a given problem. For example, characters, integers, or floating point numbers. So over here, we are talking about data. Remember, from the concept of computing and ICT, data has to do with raw facts and figures. And the data could come in different formats. It could be an audio file, it could be video, it could be pictures, it could be text, it could be numbers, it could also come in symbol forms. So these are some examples of data, and in writing the C++ program, we need to put these data into the various data types that they belong to. So since a computer uses different methods for processing and saving data, the data type must be known. The, the type defines the internal representation of the data, and then two, the amount of memory to allocate. So let's look at this scenario. A number such as 1,000 can be stored in either 2 or 4 bytes. When accessing the part of the memory in which the number is stored, it is important to read the correct number of bytes. The data type specifies the size and type of information the variable will store. Variables are containers for storing data values. So for every data at all that we have, we need to keep the data in a variable. So we'll talk about what variables are and also in data, and then how to declare some variables or how to declare your variables or the rules that govern the declaration of the variable. So over here, the variables are the containers that hold the data. So for every data, you should be able to know the type of the data, and then the data must also be stored or must also be reserved or must also be kept in a variable. All right, so that explains that aspect. So over here, let's look at some of the C++ programming data types that we know. And these are the commonly used ones. We have the single types, we have the int, we have the short, we have the long, we have the float, the double, the long double, and then char. So over here, the definition gives, the type of it or the name of it. Int means an integer. Short means short integer. Long means long integer. Float means floating decimals. And then over here, we also have the limit. That is the the size that this number can represent when we give a particular data, let's say as an integer data type or a short data type or a float double data type. We should know the limit or the amount of information that can be stored within that particular data type. And then we also have the unsigned types, that is the unsigned in, the unsigned short, unsigned long, and then the unsigned char. So those are the ones that we also have. That is the unsigned one. Those ones are from 0 to, the figures over there. And then we also have other data types that has to do with what Boolean or bool. Boolean most of the time stores only two values. That is 1 or 0, or true or false. It's either it is yes or no, true or false, 1 or 0. So over here, the limit has to do true means it is equal to 1. When the thing is false, then it means it's equal to what? 0. And these are some things that govern the concept of object-oriented programming, and C++ also have these data types. So these are some of the few data types we would consider in our concept. So a C++ compiler recognizes the fundamental types, also referred to as the built-in data types. So we have some built-in data types, and then we have derived data types. Okay, in some program it talks about the primitive data types and then the derived data type. I mean, for my students, I encourage you to make more research into this aspect of data types so that it can give you a clear understanding about the various data types that we have. So what goes into, I mean, data type declaration, and how C++ recognizes all the syntax that is used in declaring data type. Over here, the syntax have been written in the red format, meaning that you have the data type, you have the variable name, and then we also have the assignment operator, and then we have the value. I mean, this is one way by which we can declare a data type. That is, we give in the data type, and then the variable name. The variable would be the container of the data type, and then we assign value to it. There are some instances where you can only write the data type and then the variable name, and then later in the process of your code, you can assign value to the particular data type or to the particular variable you have declared. So let's look at a few examples of it, and then we have the first one over here. We have int my num is equal to 15. So over here, the data type is an integer data type, and then the variable name is my num, and then it's equal to 15, meaning that what we have a variable which is an integer data type, and then the value this variable contains is what, or the number this variable contains is 15. Okay, so that is that. We also have another data type that has to do with float, and then the variable name. So over here, the data type here is float, and then the variable name is my float num, and then is equal to 1.19.99. So it says that a floating point number. So over here, what is float? Float normally considers decimals. Okay, decimal, so you can include decimals and other things to your to your to a particular variable that you have declared. And then we also have the other aspect of numbers that has to do with double. So my double num is equal to 3.142. So this is a floating point number. So over here we have what, we have three ways by which we can deal with numbers, either by using the integer, by using the float, provided your number comes with decimals, and then you can also use the double also to represent decimal values. But the difference between the float and the decimal, the float and the double has to do with the size of data that they can contain. And then we also have the car. The car means it's a character data type. And then we have my letter, and then it's equal to Gene. So car over here stores single characters. So that is why we have Gene. We can put in, let's say, an assignment of, let's say, A, B, C, D, E, F, whichever way we can give the character. And then we also have bool. What does bool means? Bool means Boolean value. So over here it says the data type here is my Boolean is equal to true. We said initially that Boolean takes two values. It's either true or false, 1 or 0, yes or no. So that is the Boolean data type. And then we also have string, my text. String basically contains sets of characters. Okay, so we have groups of characters, and then so over here we have the word hello. So hello, I mean, is the value, and then we have the variable name as my text, and then the data type here is what, a string. So now let us look at the information that is in blue over here. The first one, we have the int, meaning that we have declared an integer data type, and then the variable name is class mark. Over here we have not assigned any value to the what, I mean, to this variable. Okay, So we came down and then we assigned a variable to it, which is equal to 35. So this is another way by which we can declare a variable. And then once we declare the variable, then we can initialize the variable with a number. Okay, so we have the int my class mark, and then we have the initialization class mark is equal to 35. So let's look at the output. The output says that see out my class mark is class mark. So when we run this program and we compile it, it will display my class mark is, and then the value that is within the data type we have declared would be displayed. So the answer that would come here is my class mark is 35. Okay, so that explains that. And then we also have another aspect where we have declared, we have written the data type, we have written the value name, the variable name, and then we have initialized it with a value which is equal to 78. So let's look at the see out. It says that I am 78 years old. So that will be the output of the what? Of this program when we run it. So over here, the variable name we have written here will come with the value, which is what? 78. Now let's look at the third aspect. It says int my num is equal to 105. So meaning that what we have declared a variable called my num, which is equal to 105. And then we also have my num is equal to 10. So now my num is equal to 10. So let me explain this, that in the process of declaring your variable and assigning value to your variable, you can also change the value of the variable that you have declared. So over here, we first declared this at int my num equals 105. And then the second statement we came, my num is equal to 10. Now, when we call this my num, what will be the output? The output is going to take the second value. So meaning that we have overridden the first value, and then we have reassigned my num to the value of what? 10. So I want us to understand this very well. Okay, if you want to keep two different variables, that is my num and then let's say my num1 or my num2, that is fine. But remember, if provided you give it the same name as my num and then you give it a new value, it is going to override the old value and then keep the new value. So I want you to take the difference between that. So let's proceed on. It says all C++ variables must be identified with unique names. So every variable that we declare must come with what? Must come with a unique name. So let's look at the information we have in blue over here at the top, where we have what? Good. It has written int minutes per hour is equal to what? 60. So over here we have declared a variable called minutes per hour, and please take note of that. It is one word. Okay, it is one word, and then it is an integer data type. The data type, the type of data is an integer, and then the value is 16. Okay, now let's look at this. It says that the comments over here says, okay, but not so easy to understand what m actually is. We have declared a variable and the data type is int, and then the variable name is m, and then we have initialized it to 16. But over here, what does the m stands for? What does the m represent? You can see that it is not a clear information giving us a particular expression of something we intend to do. So sometimes it's always advisable that to use, let's say, names that could be reasonable, or to use phrases that could explain a particular data type. Let's say we can have sum, we can have total, we can have calculate, which could be the variable name. But it is also important that we take note that the variable name we give must not be a reserved word. When it is a reserved word, C++ will trigger an error that this variable name is a reserved word. So now let's proceed on with some of the guidelines as to what we have to do with variable namings. It says that these unique names are called identifiers. So every unique name we give to a variable is called an identifier. Identifiers can be short names like X and Y, or more descriptive names like age, sum, total, volume. So that is that, as I've explained with the concept of int minutes per hour equals 60, and then int m equals what? 60. So over here, the m equals 60 is not giving a clear explanation of the variable, but the minutes per second gives us a clear understanding of what? Of that particular variable. So now let us know some of the things we need to consider. Note, it is recommended to use descriptive names in order to create understandable and maintainable code. The general rules for naming variables are: 1. The names can contain letters, digits, and underscore. 2. Names must begin with a letter or an underscore. 3. Names are case sensitive, so my var and my var are different variables. So this has to do with C++. Maybe in some other programming languages it could be the same, but with respect to C++, we say that C++ is case sensitive. So take note when you are declaring variables and let the names be as you have defined it. Step 4. It says that names cannot contain white space or special characters like these symbols that we have the number sign or the hash sign, we have the percentage and all that, meaning that what? It cannot use special characters like these. And then 5, reserved words like C++ keywords such as int cannot be used as names. So whenever you are naming a variable, make sure that it is not a reserved word. So let's proceed on with the next thing. And then over here, we are going to also talk about constants. Okay, constant. It says that when you do not want others or yourself to override existing variable values, use const, that is C-O-N-S-T keyword. This will declare the variable as constant, which means unchangeable and read only. So it means that if you want to keep a variable value static means that we don't want to change the value. Let's say const int minutes per second, and then we have 60. You know that minutes per second is always what? Is always 60 minutes. So why do we have to change the value 60? We always have to make it what? Constant. And the reason or the keyword that would help us to make that value unchangeable is the word const. So you put in the what? The const keyword before you come with the data type and then the variable name, and then you put in your what? Your assignment operator, and then the value should also be there. So over here we have const int my num is equal to 15. My num would always be 15, meaning that what? The value of my num, which is 15, would always be that, and it cannot be changed. So when we write my num later, when we write my num equals 10, meaning that we want to override the value of my num from 15 to 10, an error will be triggered. And this is the error. It says that error, assignment of read-only variable, my num. Okay, so over here, let's look at another definition of the constant. We have const float pi, which is equal to 3.14. So over here, I have just given it a simple value as 3.14. I mean, when we're growing up, it was 3.142 with some other numbers that may come with that. Okay, so that explains what constants with C++ programming. So now let's look at a perfect C++ example where we have the include IO stream using namespace std. We have explained all these things in our first chapter, okay, where we have the IO stream. The IO stream has to do with the input output stream, and then we have the using namespace std. So over here we have declared a variable as pi, and then it is of the data type double, but we have made it a constant, meaning that pi cannot be changed. Okay, so that's why we said const double pi is equal to 3.141593, and then we come in with our what? With our main method. Okay, that is int main. We also declared some variables over here as double area, comma, circuit, radius equals 5. Now, let me explain this. Over here, we have declared three variables as area, circuit, and radius. All of the data type double. So this is another way by which we can declare variables that have the same data type. Okay, so maybe double, area, circuit, and radius. They are all of the type double, or they are all of the data type double. Now, but we have not assigned value to area, we have not assigned value to the data type circuit2. The only value we have assigned to is radius. So over here we have radius is equal to 2.5. So that explains that. Now, the area is now being initialized over here. That area is equal to pi times radius times radius. So over here, the area is more or less like a formula where we have pi. What is pi? This is the value of pi. And radius times radius. What is radius? Our radius is 2.5 and then 2.5. So our area is going to be the value of pi times the value of radius times the value of radius. Now let's look at circuit. Circuit is also being initialized here with a formula which says that circuit is equal to 2 times pi times radius. Okay, so that explains that. So over here, when we output some of the variables we have declared, what do we see? We have C out radius. Radius is equal to radius. So over here, the value of the radius will be displayed over here. And then over here, we also have circumference. So over here, the value or the calculations of what is here would also be displayed at the circuit side. And then we have area. So over here, let's check the heading: circumference and area of a circle with radius 2.5. So this program basically gives us the what? The radius, the circumference, and then the area of a circle with radius 2.5. So you can also write this same code and then compile it. I mean, sometimes you can use the dev C++, and that is what I use with my student most of the time to run some of these codes. And then once you get it done, and then you run this program on your dev C++, you will see the output clearly. So now let's look at some of the keywords that would come under the C++ programming. So the keywords, also known as reserved words, have special meaning to the C++ compiler and are always written or typed in short or lower cases. So take note of that keywords or reserved words are written in lower cases. Keywords are words that the language uses for a special purpose, such as void, int, public, etc. It can be used for a variable name or function name. Below is the table of the complete set of C++ keywords. So we have a lot of them. We have catch, we have continue, we have dynamic, cast, we have false, we have if, we have namespace, public, sign, switch, try, while, virtual, void, volatile, true, to go, explicit, do, delete, enum, for, operator, private, protected, new, register, size of, and all that. So I mean, we can name all of that here, but all these, have it in mind, are reserved words in C++. Now, over here, let's look at the user input. So over here, you have already learned about the cout, that is in our first chapter, is used to output or print values. Now we will use the cin to get user input. So over here, you can display information to to the user of your code or your C++ program using the cout. And at the same time, the user can also read out the instructions and then would be asked to perform some things. What the user would do would be accepted by the system, and then maybe another output would also be generated. The ways by which we can collect information from the user into our program is using the what? The cin instruction. Okay, it's using the cin instruction. So over here, the cin is to get user input. Cin is a predefined variable that reads data from the keyboard with the extraction operator. So this is the extraction operator. We have the double greater than sign. Okay, so over here in the following example, the user can input a number which is stored in the variable x. Then we print the value of x. So over here, we have declared a variable over here as int x. We have not initialized the variable with any value. Okay, so we are going to take the value from the user and then we are going to keep it in the data type what or in the variable x. So over here, we have written a statement, type a number and press enter. So once you type the number, you press enter. It says that type a number and press enter. So over here we have C in, and then we have the double greater than sign, and then we have X. It says that what is the comment over here? Get user input from keyboard and assign it to the variable X. So over here, let's look at our C out. Your number is and then X. So over here, it displays the input value. So whatever number the user enters, your number is, let's say, would be displayed. So if the user enters 55, I mean, the second output that would come again is your number is 55. If the user enters 1000, I mean, the second instruction that would come is your number is 1000. So that explains the concept of the C in. So the C out is to display instructions to the user, and then the C in is to accept instructions from the user into the system. So that explains that. So I hope that is clear. If you have any questions pertaining to this, I would prefer that you write it in the comment section so that I can help you and we can build a good environment. So over here, let's look at some few questions that will come with what we have done so far. That is with data types, with variables, and then constants. It says write a C++ program to accept two numbers and display the results. To accept two numbers and display the results. So over here, we are going to use the C out to give out the instructions, and then we are going to use the C in to accept the two numbers, and we are going to display the results. Have it in mind that you should also declare two variables, let's say X or X and Y, or let's say number one and number two. So you should declare those values, and you can also decide to make it an integer data type, or you can make it a double, provided the person who is entering could enter a decimal number. And then it could be accepted by the C in, and then the output would be displayed. Okay, so and display the results. So that I wish we could all do that using the dev C++. Once you do that, let me know, send me the info about it. If you have any errors, send that to me, and then I'll see how best I can correct you. And then let's look at the second statement. It says write a C++ program that defines two write a C++ program that um that defines two variables for floating point numbers and initializes them with the values 123.456 and 7876.543. So it means that write a C++ program that will take two variables, and then the variable should accept these values. There's a problem with the statement over here. I'll correct that and then I'll get back to you. Then display the sum and the difference of these two numbers on the screen. So it means that after it has accepted the two numbers, and over here the values of the two numbers has been given to you. So once you declare the two variables, initialize them with the values that you have been given here. You can talk about it. We talked about the initializations of those variables or assigning values. Over here, the values have been given to you. Now, question 3. The following program contains several errors. Resolve the errors and run the program to test your changes. So what are some of the errors that you can see in this codes that have been written in question 3? Find the errors. I mean, write the errors down, or you can type all these things in your dev C++ domain and then find out the errors that may come with it. Try to rectify the errors and see how best you can you can run this code without any errors. I mean, I wish you all the best in this assignment. Get back to me if you have any challenge, and then we'll see how best to go about it. And look at every line of code that has been written. If there is any error over there, identify those errors and everything would go well. So The instructor again is J.A. Anang. Programming using C++. Thanks very much for watching. God bless you. God keep you. God strengthen you in everything that you do. I wish you all the best in whatever you do and stay blessed.